Hey guys, welcome back to another edition in geometry. It's Mr. Anderson here with you today. We're in section 7.7. We're going to talk about scale drawings and models today. All right, so first of all, our objectives: number one, interpret scale models and use scale factors to solve problems. All right, so first of all, scale model. What's a scale model? It's an object or a drawing with lengths that are proportional to the object it represents. So what this might be is a map. For example, a map. If you've ever looked at a map, I know these days you don't get out the paper maps. You get on your iPhone and look at it. But it's the same idea that the map, obviously you can't see in real time, if it's miles. You can't have a map that big, so you have to have a small map that shows you how to get from one place to the other, and they do that using a scale model. Basically, they have a what do you call it, a scale. I guess I would just be at a scale, and so the scale is just the ratio of the length on the model or the drawing to the actual object. And so that's what, up in the corner sometimes, of a map, like if this is your map, up in the corner, maybe down in the corner, it says like 1 inch equals 7 miles or something like that. That's just the scale of the map, okay? All right, so let's see how we would use this then. Here's a situation, okay, the distance between Boston and Chicago on a map is 9 inches. And so I'm going to try this here. I don't know how good I'm going to do, but, okay, United States looks something like this. There's Texas, California, Mexico's down here. I know I'm a pretty good map drawer. Pretty realistic there. Anyway, Chicago's right here somewhere. Like Lake Michigan would kind of come down like this somewhere. That's like Michigan. So maybe this is Chicago right here, and Boston's out here on the East Coast somewhere. So here, this would be Boston out here, and this would be Chicago. So the scale is 1 inch to 95 miles. So what's the actual distance? So on the map, we're saying from here to here, this would be 9 inches. Well, what's it going to be in real life? What you can do is just set up a proportion. So we're going to say, we're going to make the scale here. Remember the scale, what we just talked about is 1 inch to 95 miles. So we're going to say 1 inch to every 95 miles. Okay, that's our scale. Well, what's that going to equal? Well, we know that on the map, we measured out here 9 inches, right? So that means for every 1 inch, if it's 95 miles, we want to know what is it for 9 inches. And how far is what we don't know. So on the top here, I put the map, the scale part on the map, and then what it really measured out to be on the map, and then on the bottom is like the actual. So the scale, the actual number of miles is the actual, for every 1 inch, that's the actual miles. So for 9 inches, we want to find out how many actual miles. Well, if you've been following any of these things that we've been doing, we now have a proportion, and guess what we can do? Cross multiply, as we've done many times. And so we're just going to go 1 inch times x, or in other words, just x, and that's going to equal 9 times 95. Okay, and so in this case then, 9 times 95 would be 855, and that would be miles. So 855 miles. Okay? Does that kind of make some sense there? So we're just setting up a proportion and doing that. Now, there is, and kind of as we did this here, you could kind of see I'd made another, I think I'm going to fit it in at the bottom underneath Mexico here. Instead of, I've got another slide, but we'll just skip past that. Alternate method that you could do here is basically what we ended up doing once we cross multiplied. We found that x is just 9 times 95. And so once you know that for every 1 inch, there's 95 miles, then you just have to multiply it by 9, right? So if you can get it down to that, like what it is per inch, in a sense, you're just writing an equation. You're saying, well, the actual mileage would just be that 95 miles times how many inches, and which is basically what you did. Notice when we cross multiplied here, we got 95 times 9. Okay, so another way that you could do that is just, you could kind of think through that logically and write an equation. And here's my extra one that I was going to do all that extra work in, and I realized I don't need it, so we're going to move on. One more similar to this is Nashville, Tennessee and Memphis, Tennessee. Okay, so on this one, the numbers are a little bit trickier than that first one we had. That's why I wanted to do another one. So here's the scale. The scale is 0.4 inches to 40 miles. So the scale, 0.4 inches to 40 miles. Okay, so that comes from this. But if you measured this on the map from Memphis to Nashville, it'd be 1.5 inches. So let's set up our proportion here. Well, remember, on the top is the map, right? So that means we measured 1.5 inches on the map, so that's going to be 1.5 on top. And what we want to know is what's the actual distance. Remember, the 40 is the actual distance, and so this is the distance from Memphis to Nashville. That's going to be our x. And guess what we do? Cross multiply. Okay, so this will be 0.4x equals 40 times 1.5. And so 40 times 1.5 is 60. So I have 0.4x equals 60, and then I'll divide by 0.4. And so 60 divided by 0.4 gives me 150. So we would say, well, this would have to be 150 miles from Nashville to Memphis. Okay. Now, in the other method, what you could do is get this, see what this would be, like how many, if it was 1 inch to how many miles, and then you could multiply by 1.5. And, one way to do that is to get rid of this decimal. You could move the decimal over 1 on each of these. And so then what would you have? You'd have like a scale of 4 inches to 400 miles. And then since now you've got rid of the decimal, just divide everything by 4, so it'd be 1 inch to 100 miles. And now once you have that, you just take your 100 miles times 1.5, and that would give you 150. All right, scale factors. Okay, so first of all, in a scale factor, this is hard for people to get a lot of times. Okay, so this one thing right here that I've written down where it says it's written as a unitless ratio in simplest form. This is the thing that kind of helps me remember. What we were just doing was called the scale. Notice it was in inches to miles. There were units in there, right? Inches are units, miles are units. So when they talk about the scale factor, or what we're going to see in one of our examples here, they're going to phrase it a little bit differently. The scale factor is you're doing it so there are no units, okay? So in other words, you're trying to find out kind of what's the ratio of like how long something is compared to something else without the units. You're not doing inches and miles. You're just keeping it all kind of in the same. I don't know how it's split, but here, this is the key, unitless. Okay, and I'll show you what we do to make it unitless. And then you want to write it so the scale model comes first. Okay, so that length comes first. All right, so here's an example of how this might work. So first of all, they're going to ask for the scale. Now notice this is not the scale factor. I know it can be confusing between scale and scale factor. This is the actual scale, like what we were just doing. Okay, part B will be doing the scale factor. All right, so we have a 1923 checker cab, 6.5 inches long. The actual car was 13 feet. Well, now here we're not talking about maps. We're talking about like a scale model. Like, I don't know if you made a little scale model when you were a kid. I did, with varying degrees of success, not always very good. But we're going to do 6.5 inches to 13 feet. So, the car itself was 13 feet long, and so the model is only going to be 6.5 inches. So we're going to say, what's the scale? Well, usually if we can, we want to try to write this scale in its simplest form. And you notice we got a decimal in here, which we usually don't like to have that in a fraction. So how could I get rid of that? Well, you could, if you wanted to, like we did in that last example, just move the decimal over one place and make this 65 over 130 and then try to simplify that. Or you could say, well, this is a 0.5. This ends in 0.5. So could I not, since it's a fraction, could I not just multiply by the same thing on the top and the bottom, like maybe 2? Because if I multiply by 2, what do I get? 13 inches to 26 feet. Could I simplify that down? Sure, you notice probably pretty easily there that that's half of that, right? So that you could just, in a sense, divide by 13. And so that would make it 1 inch. That's supposed to be inch. 1 inch to 2 feet. That means inch. Okay. In case if you were wondering. All right, so that's our scale is 1 inch to 2 feet. Notice we have units in here, inches and feet. Okay, so part B then says how many times as long as the actual car is the model. This is basically kind of a fancy way of saying what's the scale factor. Okay, that's what it's saying. What's the scale factor? How many times as long? And so what we're going to do is remember what our scale was. It was 1 inch to 2 feet. So what we have to do to get it into the scale factor is we have to get rid of inches and feet. So what I have to do is I need to get something to cancel these things out. Well, this is called, what do they call this again? Trying to think of the name. No, it escapes me. But sorry about that. But what we're going to do is, remember if you have something on top and something on the bottom, remember how you can cancel that? Like if you had, I'm going to go over here, so this is unrelated to that, but let's say you had, well, I'm going to make this, let's call this 8 over 4. So in a sense, really what we've got here is we say this 8 is like saying it's 2 times 4, and this is like saying this is 1 times 4, right? And so the 4's can cancel out. That's why we can do 8 divided by 4 is 2, is we're just canceling out that 4. So the same thing works for inches and feet. Okay, so if I want to get rid of inches on the top, I have to have inches on the bottom to cross out the inches. And if I want to get rid of the feet, I have to put feet on the top to cross out the feet. Okay, well, so all I need to do is I need to know, well, this is feet and inches are what we have to use to cross this out. So what I want to know is, what's the relationship of inches and feet? Well, we know that there are 12 inches in 1 foot. So I am just multiplying this by a fraction here that's 1 foot for every 12 inches. When I multiply this now, guess what happens? The inches cancel out, the feet cancel out, and all I have to do is 1 times 1 is 1, 2 times 12 is 24. Guess what? There are no more units. All we have left, that's our scale factor, is 1/24. So in other words, it says how many times as long as the actual car is the model. So the model is what? 1/24 the length of the actual car. Okay? Does that make sense? A little tricky there. But the main thing to remember there is, what does it take to cross out those units? Top and bottom. So if the inches are on top, put inches on the bottom, feet are on the top, feet are on the bottom, put them on the top, and then see what's the relationship of those things to each other. Okay, so we get something without any units. That's the key there. Let's look at another one, because I think it's probably good to look at this. I think it's unit analysis, I think is what they call it, if I remember correctly. I was looking for some help in my book here, and I can't see it there, but I think they call it unit analysis. All right, so let's do the same thing here. What's the scale? So first of all, this is just the ratio And so we're going to say, here's a miniature replica of a fire engine. So this is 9 inches over 13.5 yards. Okay. So we want to find the scale. So again, we know, so this is a nice 0.5 here, so I could go times 2 and times 2. So this would be 18 inches for out of 27 yards, it looks like. We're just doubling the 13.5. And then if you look at this, you could simplify this. We could divide by 3 on both of these, right? And so then this would be 6 inches. Ooh, guess what? Even more, right? We could have divided by 9 the first time, if you notice. But since we've divided by 3, what can I do? I can do 3 again here, right? So you don't always, when you're simplifying, you don't always have to get the biggest number to divide by right away. I noticed 3 and we got 6/9, and I said, hey, there's 3 again in both of those. So this would end up being 2 inches to every 3 yards. Okay, so there's our scale, is 2 inches for every 3 yards. Now notice these are some different units here than what we did before. So this is going to make our next part a little bit different. So 2 inches to 3 yards. Remember that. We're going to go over here and now do the same thing. I'm going to write down my original 2 inches to 3 yards. Okay, so we can remember that. That was our original scale, but again, we're trying to find how many times as long as the model is the actual fire engine. And this is the way they've said this one too is a little bit different. I'll talk about that in a second once we find the scale factor. All right, so let's find the scale factor. So in other words, I have to multiply this by something that is going to have inches on the bottom, so that these will cross out, and yards on the top. So the yards will cross out. Okay, well, if we have 1 yard, how much is in a yard? Well, you go, well, 1 yard is 3 feet, right? So you'd say, well, if there are 3 feet in a yard, so here, let me write this out. 1 yard is 3 feet. And so in each foot, you have 12 inches, right? So if you had 3 feet, you'd have to have 36 inches, right? Does that make sense? So what I have to multiply this by is for 1 yard, there are going to be 36 inches in that yard. So this is what I'm going to multiply by, so that yards will cross out yards, inches will cross out inches, and then on the top, I just go 2 times 1 is 2. And on the bottom, 3 times 36, which would be 72. And then we could reduce this, right? Just divide by 2. So this will be looks like 1/36. This is our scale factor. Oh, what did I do? What the heck was I doing? I did 2 times 36. What's 3 times 36? That's not 72. 108. So yeah, the key thing there is I was just looking at that. So 3 times 36 is 108. And so then the scale factor is just 108 divided by 2, which is 54. So our scale factor there would be 1/54. So this is the scale factor. But look at how the way it phrased it this time said, how many times as long as the model is the actual fire engine? So they're saying, so the way that we have to say this, the way that they asked us before was exactly opposite of that. And so it's a little tricky and it's hard to kind of pay attention to. But they said, how many times as long as the model is the fire engine? So the fire engine, if the scale factor is 1/54, the fire engine is what? 54 times longer. So we would have to here say that that's supposed to be an F. The fire engine is 54 times longer. is what we would have, the way we'd have to do that. So if they would have said how many times as long as the fire engine is the model, then we'd say it's 1/54th. So in this case, they asked us backwards, kind of. So we had to say, well, it's 54 times longer. So a little tricky there. But you can see here again how we do that scale factor. If you could just remember that 3 times 36 is 108. But the key thing there is set up the thing that you multiply by where you can cross out yards and inches or whatever else you have there. All right, last one. Gerard's making a scale model of his classroom on an 11 by 17 inch sheet of paper. If the classroom is 20 feet by 32, choose an appropriate scale. Okay. So what we know is if he's going to get 20 feet in 11 inches, we have to come up with a scale that'll fit in that space. Okay, so easiest thing to do, just since do the 20 divided by 11, I get about 1.8. And then, so that means for each inch that you do, you would have to do at least 1.8 feet. Okay, so for each inch, you'd have to have at least 1.8 feet. And then let's see what the other one would do. If we did 32 divided by 17, again, let's see how many, what it would take to get 32 feet on 17 inches. So I get there approximately 1.88. 1.9-ish. Both of those are pretty close to each other, and you notice that so what I could do here is this. I don't want to use a scale factor of that. Just go up maybe to the next highest thing. We could both take these to 2, right? So we could make a scale and say for each inch there will be 2 feet. Okay, right? Because for each inch here, if we went 11 inches times 1.8, we would get 20. So we want to make, if we do basically, I'm trying to think the best way to explain this is you want to have this a little bit more. So for each inch, you're going to cover a little bit more feet. So that way it'll fit on the paper. You don't want to go less than 1.8 because then it would go off the paper. But if it's bigger than this, in this case 2 feet, it needs to be a little bit bigger. So that means for each inch, instead of going 1.8 feet, you're going to go 2 feet. So that way it'll fit on your paper. You probably could go 1 inch to 3 feet, which would fit on the paper as well. It'd be a little bit smaller on your paper, but this would fit it really nicely here. So that was one thing, choose an appropriate scale, and then determine its dimensions. So if this is your scale here, 1 inch to 2 feet, then you would say, well, we've got the drawing. Okay, so our drawing then would have to be what? If we have 1 inch is 2 feet, then what you're going to do is you got 20 feet. And so if you can take your 20 feet and divide that by here, the 2 feet, that will tell you that you're going to have 10 inches that way. So 10 inches times 2 feet, that'll give you your 20. And then the 32, then you'll have 32 feet divided by 2 inches, or 2 feet, sorry, 32 feet divided by 2 feet, that's going to give you 16. And so that means you'd have 16 inches. So if you have 16 inches, every inch is 2 feet, that'd give you 32. So then your final dimension drawings would be 10 inches by 16 inches. I should have written inches in there. So 10 by 16 would be your dimensions of your drawing. So you can notice that would fit on a 11 by 17 sheet of paper. It'd be 1 inch less on each side. Okay, that's it. This is Mr. Anderson. Hoping you have a great day. That was section 7.7. We'll see you next time in chapter 8. Bye.